powering this thing for the first time. Here we go. 3, 2, 1. See, this thing is drawing around 5 amps. I wonder why. Oh shit. Hello, what's up? In the last video, I showed you how this thing killed my Raspberry Pi. In that video, I also showed you that I designed a crowbar circuit which will protect this Pi, or rather a future Pi, against a future module. See, I still want to use these modules because there is not really that many options available to use your Raspberry Pi from your 3D printer power supply, which is a 24 volts thing. So these modules comes in very handy because these convert that 24 volts into 5 volts, and these also have a USB port in it. So it becomes very easy to just use a Type-C cable from here and power your Raspberry Pi using that. Watch that video from the cards above if you haven't already. So see, this is the circuit I designed. This is a generic crowbar circuit, but I have made it overkill because I have used a voltage reference. See, these are precision voltage shunts. Those are used for precise voltage reference. So this circuit I'm not going into detail. If you want me to, just leave a comment down below. I'll make a future video about it. But basically, we turn on this thyristor, you see. It is a BT151, and we just turn on this whenever we detect a voltage spike or an over voltage. This doesn't really understand the difference between a voltage spike and an over voltage, you know. For a voltage spike, I've also included this TVS diode. I've done my share of experience with this TVS diodes in my last video. You can watch it again if you haven't already. As I'm going to make this into a PCB, I have run a bunch of simulations. See, basically it will blow this fuse away if the voltage increases than a set value. And here's the PCB, as you can see. I have put a lot of input options. See, I have terminal jack, I have a micro USB port as well as the Type-C port. And for output, I have this Type A port and a terminal jack or terminal post or whatever that is called. You see, I put a lot of Easter eggs. Isn't it look beautiful? Well, it better work. I've already ordered this PCB and it is arriving today. Any moment now.
One eternity later.
See, I again got absolutely ripped off. This is the first time of me ordering from JLC PCB, and I didn't know that UPS charges extra for handling custom duty. Now I paid like the same amount in service charge and custom duty as I paid for the entire PCB plus the shipping cost. Again guys, this video is becoming increasingly expensive. Like, share and subscribe to give me some motivation. There is only one positive part, I guess. That is the quality of this PCB. See? All my Easter eggs are looking awesome. And also for some extra challenge, as you may already have seen, I have made this entire PCB surface mount, except certain components. So now you guys can watch me struggle to solder tiny components for the first time. Hopefully my microscope will come in handy. You can also skip to this timestamp if you don't want to see me solder the components. I ordered some ESD shape gloves, but they have given me like kids gloves, man. What the hell? There you go. See, I bought this cheap ass microscope and it seems like I cannot even reduce the brightness of the display. So there is no harm in giving you a satisfying peel though. You see, looks like I f***ed this area up already. Looks like my solder paste is not in a good shape. This thing apparently has to be freezed. Obviously I didn't, so I'll add some flux to revive it. You know, because a little bit of flux can fix everything.
Nope. 2 hours later.
Is that a little bit though? Probably too much. I'll not talk anymore. Let you guys enjoy my screw-ups. See, doesn't it look cool? Looks amazing. And I'm really proud that first time I soldered these tiny components. See? But you know, it looks good and all. But it's time to check if this thing actually works or not. See, I've set the power supply to 5.2 volts and set the current limit to maximum, that is 5 amps. Because why not? This thing is protected anyway. And this crowbar part will not fire before, let's say, 5.5 volts. So we are safe. Nope. Here we go. 3, 2, 1. Wait, what? See, this thing is drawing around 5 amps. I wonder why. Oh, shit. Piece of shit.
The greatest
Idiot.
that's ever lived.
My wire's absolutely melted. I'm an idiot. I put the TVS diode backwards. TVS diodes are like Zener diodes. You have to put them in reverse bias. I put them like a normal diode. So the whole current went through it. You might be thinking, how the fuse didn't blow open then? Well, I plan on using a 2 amp fuse, but for some reason, here I put a 10 amp fuse. Moral of the story? Don't be a moron. Here goes my 2 amp fuse now. Fuse clicking ASMR. Now, we will check the turn on characteristic of this thing. Testing the normal operation in 3, 2, 1. The whole thing takes a time of around 30 milliseconds to turn on. Now, let's test the fault condition. For that, I will just set the voltage here to 5.45 volts. Because that is where the activation is.
Eventually.
There. That's the closest we are gonna go because the thing is too sensitive. Even the fine knob is too sensitive for this sort of adjustments. 5.45 volts now, and I will not put any current limit because I want the fuse to blow so that we can see. We must see how the fuse blows, and there will be a voltage buckle in the scope. We will be able to see how much time it takes. That's where we are interested also, because that will be the response time of this thing. So see. Here we will be able to see the output voltage coming out of this. Here you will be able to see both the input and output. The input will be the yellow channel and the output will be the green channel. So here we go. Testing my crowbar circuit response time in 3, 2, 1.
You f***ed up.
And just like that, guys, I messed up the scope settings. There goes another fuse. I've replaced the fuse now, so try 2. Testing the pi protector crowbar circuit response time in 3, 2, 1. See? It works as expected. Give this video a thumbs up for that. So you might think, why both of the LEDs are lit up? That's because there is no load at the output. If there is a load attached to it, like a pi for example, and it tries to draw current, you see this 4 volts here, it will drop to 0 volts, or maybe not 0, it will be close to 0, and the whole current will pass through this LED and buzzer. So the red LED will light up brighter, the buzzer will sound louder, and this path, this green LED, will not lit up at all. Let me show you what I mean. See, I have this 5 ohm load resistor here. 3, 2, 1. Come on, you piece of shit. See, the voltage here is not 4 volts anymore, and the output LED is not working anymore, the green one. Shit. My ears. That will how it sound when there is a pi attached to it. It works exactly as I designed it, which is pretty rare thing to occur in this channel. Give it a thumbs up for that. See, I'm being generous here. And I put this cursor as 20 milliseconds apart from each other. So you see AY is at 5.36 volts and BY is at 5.48 volts. So realistically, this thing takes less than 20 milliseconds to activate, which is awesome, isn't it? Now let's do an even more realistic test with this broken XY3606 module and see how it performs in real world. 3, 2, 1. What the hell is that? What the f***? Something is what? Oh my sh**. I'm an idiot. See, the last time I connected it backwards. See, this thing has an input side and an output side. See, this is the input side and this is the output side. And I connected it backwards. The PCB is over-engineered, that's why it took all the current, but my wires melted. See, even my new oscilloscope probe, that also melted. For the first try, I have disconnected this from this because I want to see how this performs for the first time. You may remember from my last video, this have a mind of its own. It is not consistent at all whatsoever. So I want to see how this performs first. And with that, I'll also set my scope so that I don't miss the peak. I don't have a lot of fuses left, so I have to do this within couple tries. I can't waste fuses anymore. It's not even turning on now.
You f***ed up.
I am an idiot. See, I completely forgot that the scope grounds are common. See, I disconnected this ground wire only. But the scope grounds are connected to its output and the ground path is a common ground in this circuit. So me plugging this wire in it doesn't even matter. And just like that, I blown another fuse. See, this is my setup. Hopefully, I have to do this just once now. So see, this yellow channel here is this piece of and the green channel here is the output of this. Also, the output of this is connected to a 5 ohm load. So basically it should draw 1 amp. That same output of this thing is connected to this meter also. I will also set the meter to max. So hopefully I have to only do once. Testing the pi protector in action. 3, 2, 1. Nope. Testing the pi protector in action. In 3, 2, 1. Nope. Testing the pi protector in action. In 3, 2, 1. What is this? What the actual?
You f***ed up.
Piece of shit. Testing the pi protector in 3, 2, 1. No. 3, 2, 1. No. 3, 2, 1. Nah. Testing the pi protector in action in 3, 2, 1. There you go. We got it finally. See, the output voltage was the pi will face is 5.36 volts. The sound of joy, the sound of victory. My ears. See, I was thinking of throwing this thing out, but then I realized that I got a comment in my previous video that these things apparently everyone says to not use them with the pi. I also did a search and I couldn't really find such videos on YouTube. So I guess I'll be that guy. We'll study this further and we'll see whether you should use these modules with your pi or not. Because well, these are cheap, but what if we could replace one of these components and improve it, you know? And I'm pretty confident I can do that. Because the circuit and all works really good, but the components are the thing. Because to make this cheap, they use cheap components. And I'm pretty certain about that because see, I have also used this surface mount capacitor in my circuit and this is a really good one. This is from the brand Nishikon and one of these capacitors cost a lot of money. So I don't think they can sustain making these modules at such cheap price. So I'm pretty sure they skimp on these components. If we can use the circuit board and source our own components, then we can really make these perform consistently. And hopefully they will not even go bad to the point that it will kill a pi. With that, I will also use my Crowbar circuit because I really started to like this thing. I have left all the Gerber files and circuit diagrams in the link in the description. So if you also want to make yours, you can just order the PCB from my Gerber files. So that will be the topic for the next video maybe, where I will see which of the part in this component, which I'm pretty sure probably the resistor divider, which should be the part of the feedback network, is messed up. So you just have to loose wires. Keep away from your body parts. So we will see which of the parts in this module can you replace to make it good as new. Subscribe to this so that you don't miss out to that video. Give this video a thumbs up if you liked. Thumbs down for the opposite. Shut the f***. Keep your best wishes for this dead pi in the comment section down below. And I'll see you in the next one. Peace out.